तुम्ही आडवी दिसायला त्याच्यामध्ये स्क्रीनला दिसतात. बरोबर, राहू दे.
हाँ गायकवाड़ सर,
सर
बाकी के दो जो है ना आपके माइक
हाँ सर,
ऑफ रखने के, जब बोलेंगे तब जिसका उसका उपचार
हाँ ठीक है सर, ठीक है ठीक है ठीक है।
ठीक है। अभी तो हैमिंग बंद हो गई, ठीक है।
हाँ ठीक है सर, कर दिया कर दिया।
Now, हाँ गायकवाड़ सर, शुरू करने का क्या?
प्लीज सर।
Now, welcome to the lecture series jointly organized by Maulana Azad College, Aurangabad and Arts, Commerce and Science College, Kille Darur, under MOU between us on the topic chemical bonding and molecular structures. Today's lecture will be delivered by Ashok Bhosle sir. Now I request Milind Gaikwad sir, Dr. Milind Gaikwad sir, Professor and Head, Department of Chemistry, MSP Mandals, Arts, Commerce and Science College, Kille Darur, to introduce Ashok Bhosle sir.
Thank you, sir. It is a great pleasure for me. Today I am introducing Mr. Ashok Bhosle sir. Before to start his introduction, I quote one point, because we have already started this lecture series from last day with Maulana Azad College, Aurangabad, and MS Mandal's Art, Commerce and Science College, Kille Darur. This lecture series will be definitely benefited to the students. So with this brief introduction, I introduce Mr. Ashok Bhosle sir. He has completed his MSc in Analytical Chemistry in 2018, acquiring 8.35 CGPA. He has passed SET examination in 2020 in chemistry. He also passed CSIR NET in 2020, also GATE examination in 2021. He has also passed CSIR NET in 2022, also GRF having number 62 in chemistry. He has also completed 1 month FDA training at Aurangabad on HPLC, ultraviolet and dissolution apparatus. With this brief introduction, I request Mr. Ashok Bhosle to deliver his lecture on chemical bonding. Please proceed over, Mr. Ashok Bhosle, sir.
Thank you, sir. Am I audible? Okay. First of all, good evening, all of you. I am Ashok Bhosle, working as an assistant professor at Art, Commerce and Science College, Kille Darur. Today, I will deliver the lecture on the chemical bonding and molecular structure. Today, I will cover only syllabus point given by our university, Dr. Babasaheb Ambedkar Marathwada University. Let's start with first point, the concept of hybridization. Okay, I will share on digital board because I don't have slide. That's why I will share on our digital board. Now, I start from the concept of hybridization. First, hybridization. This is, can I, okay. Here are some network issue. First, the hybridization means we generally all of we heard the word hybrid. Hybrid means two things combined and formation of new things. In this same concept apply in our chemistry also. Chemistry, molecule also. First, the scientific definition of hybridization is the intermixing of atomic orbitals and formation of new hybrid orbitals. The definition of the hybridization is intermixing of same or nearly same energy atomic orbitals and formation of two new hybrid orbitals of same energy. That is called as hybridization. That is called as hybridization. Now, we will discuss some theory points regarding the hybridization. First, we saw the definition of the hybridization. Then, half-filled orbitals and empty filled orbital, also full-filled orbitals shows the hybridization. And third point, the number of hybrid orbitals is equal to number of atomic intermixing orbital. It means, suppose one atomic orbitals and another atomic orbitals we are mixing two atomic orbitals and formation of two hybrid orbitals. Now let's take one example for hybrid orbital. How formation of hybrid orbitals? First, suppose we take one s orbital, one s orbital, and another is p orbital. Another is p orbital and formation of new two hybrid orbitals. Two new hybrid orbitals. Then the fourth point is the concept of hybridization is only for sigma bond and lone pair, not for double one. I think sir problem issue network का issue.
Bhosle sir,
सर जी यहाँ का स्क्रीन शेयर नहीं हो रहा है
Connecting network issue.
नेटवर्क का
और अभी ये इसमें कर
हाँ भोसले सर एडमिन ज्वाइन ही नहीं है. हेलो. हाँ गायकवाड़ सर.
हेलो.
एडमिन ज्वाइन नहीं है ना
हेलो
सर.
सर.
हाँ एडमिन ज्वाइन नहीं है.
हेलो.
हाँ एडमिन ज्वाइन नहीं है. एडमिन
एडमिन ज्वाइन है ना सर.
नेटवर्क इशू.
नेटवर्क का प्रॉब्लम दिखाई दे रहा है सर.
हो हो.
हो ठीक आहे. झालंय मध्ये प्रॉब्लेम आहे दुसरा. आता होस्ट करा नाव. आता होस्ट करा.
अभी भी होल्ड करो सर.
कनेक्ट झालं.
सर हो गया एडमिन भी. होस्ट
हो गया ना. ओके.
चालतं तसं. तर नाही प्रॉब्लेम नाही लागला याच्यावर. असं शूट करावं लागलं. आपण हे व्हाईट बोर्ड यूज करू तिला ते आहे ते इथं झूमच कट करू. झूम डायरेक्ट त्याच्यावरच टाइम चालला आपण. लाईट बंद करावं लागतं सर. ती लाईट बंद करावं लागतं. सर इथे येते ना सर. तसं नाही तर काय तुमचा व्हिडिओ चालू केला ना हे हे करा आता दाखव. तसं नाही दाखवा लागला पाठीमागचा कॅमेरा तुम्ही होणार ना. तुमचा कॅमेरा खराब होतो. माझ्या ह्याच्यावर करा. तो प्रॉब्लेम घेतलं मी त्याला. दिसते ना व्यवस्थित दिसला पाहिजे. लाईट बंद करावं लागतं थोडं. क्लियर आहे का? इज विजिबल नाही ते पण सगळ्यांना yes is visible yes okay now we start with concept of we started with concept of hybridization. Now let's explain. I will explain some points regarding the hybridization. First, definition of, we take the first definition of hybridization. Hybridization means intermixing of atomic orbitals and formation of new hybrid orbitals. Then let's take one example. We take s orbital. This is the atomic orbital, s orbital, and another is the, we take p orbital. We take here two orbitals here, and this one and another two p orbitals. This 1, 2, 3. These three atomic orbitals intermix with each other, and formation of new three hybrid orbitals. 1, 2, 3. Three hybrid orbitals. This is the hybrid orbitals. How three hybrid orbitals form from the atomic orbitals? From atomic orbitals. This is the, how many orbitals are hybrid formed? By intermixing of three atomic orbitals and formation of also three hybrid orbitals. Now, another next point is how hybrid orbitals are named. See here how hybrid orbitals are named. Here we take s orbital and two p orbitals. Here now how we can name these orbitals. This is the sp2. Yes means from this s orbital, and p2 means this 1 and 2 p orbitals. And next orbital is also called as sp2 orbitals. sp2 orbitals. The name of this orbital is sp2. Then Now I will explain the different types of hybridization. Different types of hybridization. Different types of hybridization. Okay. Now, first hybridization. Now, take an example. To take first s orbitals, one s orbital, and another is one p orbitals. Or suppose we take 2p and 2s. These orbitals, this is the atomic orbital. This is the atomic orbital. This atomic orbital. And also this is the atomic orbital. This is the atomic orbital. Now, these two atomic orbitals are intermixed, and formation of new only two orbitals. Why two? Because of we are mixing only two atomic orbitals. We just look before some time. I said you suppose we mix two atomic orbitals and they will form only two hybrid orbitals. Hybrid orbitals. Now, these orbitals, how we can name these orbitals? We just look. This is a s and p orbitals. Also, s and p orbitals. S and p means one. This s, and this p. This is the sp orbital. This is the sp orbital. This is the hybrid orbitals. This sp means this is the type of hybridization. sp hybridized. Having sp hybridization having the linear geometry and angle between the orbitals is 180. Now we look the orientation of the sp hybrid orbitals. Now we see the orientation of how sp hybrid orbitals are oriented. sp hybrid orbitals are oriented. See here, this is the one. This is the one hybrid orbital. This is the shape of hybrid orbitals. First orbital. This is the shape of hybrid orbitals. This is the large lobe, and this is the small lobe. Now this sp, this is the s, and another, this is the p. This is the s, this is the p. Two orbitals. This is the two orbitals away from the each other by 180 angle. 180 angle means these two orbitals are having minimum repulsion. They are come away from each other due to their stability. These two orbitals acquire minimum repulsion for their stability and also their geometry. This is the, now we can say this is the linear. Linear means two orbitals having between two orbitals having 180 angle. 180 angle, having less repulsion between these two orbitals for stability of. This is the sp. This is the sp hybridized orbital orientation. Now we take the first example of sp hybridization molecule. sp hybridization molecule. sp hybridization molecule. First we take the beryllium fluoride. Barium fluoride. First example BeF2. This is the example BeF2. Barium having two fluorine atoms. Two fluorine atoms. Now we have to determine the shape of our shape, structure, their geometry, and hybridization of the barium difluoride. Now, how we can determine? Now we will discuss the detailed explanation of that hybridization, structure, shape of the barium fluoride. Let's start with the beryllium. Beryllium having the atomic number 4. Beryllium having atomic number 4. Their electronic configuration is 1s2, 2s2, 2p0. Because we have only 2 electrons here. Look, this is the 4 electron. Here 1s2 having 2 electron, 2s2 having 2 electron. Now complete 4 electrons here. But for the bond formation between beryllium and fluorine, it requires the unpaired electron between both the atoms. Means barium should have the 2 unpaired electrons. Barium require 2 unpaired electrons. 2 unpaired electrons for the bond formation with fluorine atom. Each fluorine atom. One unpaired electron will bond form with one fluorine, and another barium atom having one unpaired electron, remaining unpaired electron with bond form with fluorine atom. Now, but here is the unfortunately unfortunately we have in the valence shell. Here, look. Here the valence shell in s orbital having the paired electron. Means in s orbital having 2 electrons. These electrons are paired. These electrons are paired. These paired electrons are not participate in the bonding. But for the bond formation, we require the unpaired electron. How many unpaired electrons? 2 unpaired electrons. Because of we have 2 fluorine atoms attached to the barium atom, and that's why beryllium must have the 2 unpaired electrons. This is the barium having. This is the ground state. For the unpaired electron formation, we have to do excitation of electron from ground state to excited state. This is the ground state. Now, first we excite the electron. One electron excites to next orbital. Next orbitals. Here we look. Here the 2s orbital having 2 electrons, and next orbital is a 2p. This is the empty orbital. P orbital having 0 electron. This is the empty orbital. Now the electron move towards the electron jump from 2s orbital to 2p orbitals. Here, what will happen? This is the ground state. Here is the p orbital. This is the p orbital is the empty. It does not have any electron. Now here one electron for the unpaired electron, one electron jumps from s orbital to is the p orbital. P orbital jumps from one orbital to next orbital. How will look now? This is the s orbital. Here is the only one electron, and another electron move to second next p orbital. This is the 1, 2, 3, and first electron having one electron. First orbital having one electron. Now this is the 2s. This is the 2p. Having one electron. Now what we wanted, the two unpaired electron we wanted. Here we got the two unpaired electron. These are two unpaired electrons will bond form with the fluorine unpaired electron. This is for beryllium. Now we see the fluorine atom. Fluorine atom must have also the unpaired electron. Here the fluorine atom having atomic number 9. Atomic number 9. And electronic configuration is 1s2, 2s2, 2p5. This is a 9. 2 plus 2, 4 plus 5, 9. Total 9. Now we consider only the last valence electron set. Last electron valence set. Here 2p5. Here the how in orbitals, this is the p orbitals having 3 orbitals, 1, 2, 3, 4, and 5. Here the one unpaired electron here. For this is the unpaired electron. One unpaired electron, and another okay. Now let's see here. Let's see the how will bond form between fluorine atom and beryllium atom, because we have now beryllium. We have beryllium having two unpaired electrons. This one, and this is the in 2s one orbital. In 2s orbital one electron, and having also 2p orbital having one electron. Now this is the atomic orbitals. These both orbitals are atomic orbitals. Now these atomic orbitals are hybridized or intermixed with each other, and formation of new hybrid orbitals. How many orbitals will form? Only two hybrid orbitals. Because we have only this 2s orbital and one 2p orbital. 2s orbital having one 2p orbital. These only two electrons are intermixed. These two orbitals are not intermix because it doesn't have any electron. That's why only we are mixing only two orbitals. Which orbitals? 2s and 2p orbitals we are mixing. This is the atomic orbitals and formation of the new hybrid orbitals. New hybrid orbitals. Now, new orbital. Look, here the one electron and one electron from this 2s and 2p orbital. These orbitals, how we can name this hybrid orbitals? This is the sp orbitals, and also this is the sp orbitals. Sp how? This is the sum of. This is the s orbitals combined with p orbital. That's why we are naming this orbital is s and sp combined. This is the hybrid orbital one. This is the hybrid orbital second. Now these two atomic hybrid orbitals having the two unpaired electrons. That two unpaired electrons will bond form with each fluorine atom. Each fluorine atom. See here. See here. Fluorine atom also have fluorine atom also have one unpaired electron. We look here. Here is the unpaired electron. Each fluorine atom having one unpaired electron. This is the one fluorine atom, and another is a fluorine here. 1, 2, 3, 4, and 5. This is a also one unpaired electron and also one unpaired electron. Now this unpaired electron and this unpaired electron will meet bond. This orbital having one unpaired electron and this orbital is having one unpaired electron. Now bond will make between that and the orbitals. Here the orientation. Now how the orientation between the beryllium and fluorine atom. Beryllium and fluorine atom. Now we see the orientation of actual beryllium and fluorine atoms, their orbitals orientation. See here, beryllium having, this is the one orbital, another is a one orbital having one unpaired electron, and also barium having one electron. Means barium have two unpaired electrons, and these orbitals are intermixed with, this is the one fluorine, another is a one fluorine atom. Here also one atomic orbitals. Here also this orbitals. See. Here, one barium having here one unpaired electron and fluorine atom having one unpaired electron are intermixed or will bond form between this unpaired electron. Here also same. This is the one from beryllium and one from beryllium atom. This is the bond will form between the beryllium and a fluorine atom. This orbital is called as sp orbital. Hybridization of the sp. This is the hybrid orbital sp. This is the structure of BeF2. This is the structure of BeF2. Now we will discuss the next hybridization types. Next type. Next type. Let's take one s orbital, type number 2, type number 2, type number 2. This is the one s orbital, one orbital s, and another is to take two p orbitals, two p orbitals. This one p and this is the one p. Now we look just before some time. We saw these atomic orbitals. This is the atomic orbitals. Atomic orbitals. These atomic orbitals will intermix. Now here are three atomic orbitals. This 1, 2, and 3. Three atomic orbitals are intermixed. These three atomic orbitals intermix and formation of the hybrid orbitals. How many hybrid orbitals? Three, only three. Because of we are mixing only three atomic orbitals. That's why we are forming only three hybrid orbitals. This is the three hybrid orbitals. Now, how we can name these hybrid orbitals? Look here. This is the one. This is the sp2. sp2. One. This is the s from this one. This s and two orbitals. These two orbitals. This p. This is the sp2 hybrid orbitals. sp2. This is called as sp2 hybridization. sp2 hybridization. In sp2 hybridization, their geometry is trigonal planar, and their bond angle between the orbitals 120. There, see here. The sp2 hybridization having geometry trigonal planar and angle 120. Now we see the orientation of the sp2 hybridization. How sp2 orbitals are oriented between them. We have three hybrid orbitals. This is the orientation of sp2 hybridization. This is the sp2 hybridization orientation. The bond angle between these two orbitals is 120 angle. How much? 120 angle. Each orbitals between these two orbitals between 120 bond angle. 120 bond angle. This is the sp2 hybridization or orbital orientation. Now we look the example which I will explain now the details explanation of the one example of sp2 hybridization. sp2 hybridization. We are take first example. We are taking the BF2. This is the famous molecule BF3. Now, we have to determine the BF3. We have to determine the structure, shape, we have to determine the structure, shape, and geometry of that molecule. BF3 molecule. Let's start with the The boron atom. Let's start with boron atom. Boron atom having atomic number is 5. Atomic number 5, and their electronic configuration is 1s2, 2s2, 2p1, because we have only 5 electrons. That's why this 1s2 orbitals are filled, 2s2 orbitals are filled, and 1 electron in 2p orbitals. Here 2p orbitals. Here we just take the valence shell. For the bond formation, boron must have the 3 unpaired electron. 3 unpaired electron. Because why 3 unpaired electron? Because boron surrounding 3 fluorine atoms. That's why boron must have 3 unpaired electrons. 1 unpaired electron bonds with the fluorine atom, another unpaired electron bond with fluorine atom. Also, last third electron also unpaired electron will bond form with third fluorine atom. Now we discuss how the bond will form. Let's we are consider only last valence cell. 2s2 and 2p1, and their orbitals in 2s orbitals having 2 electrons, and another p orbitals having only 1 electron. Here 2 p orbitals are empty. 2 orbitals are empty. So now what we require, the boron requires the 3 unpaired electron, but we have only 1 unpaired electron. Now we have to do now, the excitation of electron from this 2s orbital to this the p orbital. One electron move from s orbital to 2s to 2p orbital. This is the 2 to 2. One electron move from 2s orbital to 2p orbitals. How will look now? Here in 2s orbitals contains only 1 electron. 1 electron move to next p orbitals, and another here 1 and second. 1 electron from this electron came from the s orbital. This electron came from these s orbitals, because the 3 unpaired electron required for the bond formation with the fluorine atoms. Here we have 3 unpaired electrons. 3 unpaired electrons now. 3 unpaired electrons are the intermixed and formation of the 3 new hybrid orbitals. How many? 3 hybrid orbitals. One orbital, 2 orbitals, and this is the third orbital are intermixed. They are intermixing with each other. And formation of new 3 atomic orbitals. 3 atomic orbitals. 1, 2, and 3. 1, 2, 3. An electron, here 1 electron, another and third electron. Now this is the hybrid orbital. This is the hybrid orbitals. Now these hybrid orbitals are formed bond with fluorine atoms. Now we look the fluorine atom. Fluorine unpaired electron. Each fluorine atom unpaired electron. Each fluorine. There also each fluorine atom must have the 1 unpaired electron. 1 unpaired electron. Now let's see the fluorine atom. See, fluorine atoms having 9 atomic number. 9 atomic number. What happened? Tell me. Putting in. एक से जास्ती चालू करी. Hello. Am I audible?
Mr. Bhosle, sir. Hello. 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 Bhosle, sir. Hello.